Hey everybody, it's Miss C, fourth grade teacher at Syracuse Academy of Science and Citizenship Charter School. Today is our second lesson on waves. I hope that you've learned a lot. I hope that you really enjoyed that experiment for Friday. That is a lot of fun to do. It's really interesting to feel the vibrations from the spoon and hear the sound travel up and into your ears on that string. It's really, really cool, and that's an experiment I really enjoy doing with my students that I did in the beginning of the year. So I hope that you enjoyed that. And today we are going to be talking about different properties of waves. So we learned about the crest, which is the top of a wave. We learned about the trough, which is the lowest part of the wave. So crest is highest, trough is lowest. Now we're going to be learning about some other different things. We're going to be learning about. Let's first look at our slideshow. And it says, have you ever been to the ocean? Did you see people surfing on the waves? So maybe some of you have been to the ocean. You've seen some people surfing. I know that on Oneida Lake, people will go surfing sometimes because the waves will get pretty big. Not this big, but they'll get pretty big. I myself have never gone surfing, but I think it would be really cool. What questions do you have about this phenomenon? It says water waves can be big and fast enough to surf on. Let's watch this cool video. There goes that person. They just rode the wave out. They're still riding it. That's very cool. So what questions do you have about people who can surf on waves, about those waves that we are able to put aboard and basically glide with it and move around on it? That's what surfing is, right? We're riding the wave. So what kind of questions do you have about that? I guess my questions would be, how fast is that wave going? How high is that wave? How fast does a wave have to be going in order to be able to push someone like that in a way where they can actually just coast on the wave? You can do at home. You can fill a plastic container with water and then move it around in different ways. And you can look at the different waves that you make. And you can see if moving it fast does something different to the waves that are made than moving it slow, maybe in different directions. That's a fun activity that you can do at home. Of what you already know about the different types of waves and their properties, write questions you have. So maybe your question is, do all waves move in the same way? Do all waves travel at the same speed? So those are some questions that I have, so maybe you have some different questions. So by the end of this lesson, we are going to be able to explain water waves can be big and fast enough to surf on. So there is an activity that you can do at home with the water waves. That's where you can just put it in a container and move it around and experiment and see what different movements and different speeds does to the waves. So today we're going to be looking at modeling waves. We have our picture here, and it says amplitude. Amplitude is how big a wave's crests are. So how big do you think that wave that we just saw in the beginning where the person was surfing on it, do you think it had a big amplitude? Where its crests, the highest point of it here, really high? It says a wave with small amplitude has small crests. So I would say that that wave that that person was riding on, those crests were huge. They were riding on the crest. So that wave had very high amplitude. Now wavelength is how far apart the wave's crests are. So if we look here, here's a crest, and here's another crest. The wavelength is going to be here between them. It is the distance between each crest. So wavelength, if the crests are far apart, it has a long wavelength. If the crests are closer together, it has a shorter wavelength. So say that this, instead of this crest being here, maybe it was right here. Then we would say the wavelength was much shorter than this wavelength. Here we see that this person has their container with their water in it, and what we can do is you can create different waves that have different properties. And so the properties are the amplitude and the wavelength. So I would say that this wave has a very long wavelength because I don't even see another crest for it. Here's the crest, here's the trough. I don't see another crest. So I'd say it has a long wavelength, and I would say it has large amplitude because the amplitude is measuring the size of the crests. So here we can draw a diagram of each of the four water waves you make in your container. So this is just an activity that you can do at home. So if I had done it at home, I know that something with small amplitude would have smaller crests. So I'm going to put a dot above each crest. So that would be small amplitude. Large amplitude would be something that has very high crests. So you don't have to put these dots there, but I'm just putting dots there so you can see that this is the crest, so is this, and so is this. Now, wavelength. Wavelength is the distance between the crests. So if we wanted short wavelength, we would say those crests are going to be right next to each other. A long wavelength, it would be do you see that the distance here between each crest is much longer than the distance here? These crests can almost touch each other. So we know this has a short wavelength, this has a long wavelength. Now, this is an activity that you do with the spring, but we're not going to do that today because I don't have a spring. So it says complete the following statements to explain your model of what waves are and how you can describe them. We modeled 3 examples of waves. I only modeled 1, so I'm going to put down water, but in theory, we also would have modeled sound. The shape and size of all these waves are described by 2 properties. So what 2 properties have we been talking about? What was our vocabulary today? It was amplitude and wavelength. Now we can describe them. We can say that amplitude is the size of the crests and troughs. Wavelength is the distance between the crests and troughs. So, to conclude, properties can be used to describe patterns in waves. We can explain each of them. So those were amplitude, that was the wavelength. And to go back to what is a wave, what are 3 examples of waves? Waves can be sound, they can be water, they can be light. Light moves in waves. Why is it helpful to use real objects and diagrams to model waves? Like anything, when we create a model, it is taking something that is maybe very abstract, which means hard to picture when it's described to you, or maybe something that is too big to see. And a model helps us simplify it. It makes it very simple. It helps us look at it in a way that we wouldn't be able to see it before. Because as I'm talking right now, can you see the wavelengths traveling, the sound waves traveling out of my mouth? No, but when we did this, we were able to create a model of that. Why is it helpful to, how did the models help you better understand the patterns in amplitude and wavelength? So this is something for you to reflect on. How does modeling help you better understand something? Okay, so that is it for today. I hope that you enjoyed this lesson and that you enjoyed the way that TCI kind of makes things more interactive. This is something that I would want you to be able to do with a partner, but you can just do them at home with your family for now. So go ahead. So now please go ahead and fill out the exit ticket and stay tuned for our lesson on social studies on Wednesday.